In this video, we're going to talk about 4.2, which is applying congruence to triangles. It's basically if we have two triangles or two figures that are congruent, we can line up the different sides and angles that will also be congruent. So congruent just means that we have congruent or geometric figures need to have the same size and the same shape. And we know that all corresponding parts of congruent figures are congruent. This means that if we already know that two figures are congruent, that we know that we can line up all the different angles and sides that will also be congruent. So for some pictures that would be of congruent figures, these are two squares. So I made all of them have the same congruent sides, so our congruent figures, and then the congruent angles. So since I have 90 degrees for all of them, then they all are congruent. So for an example of non-congruent figures, this is what it may look like. You can see that they're the same shape, but they are not the same size. And for them to be congruent, we need them to be the same size and the same shape. So now that we know that two figures are congruent, we can make the corresponding sides or vertices congruent as well. So in this first picture, you can see that for a congruent statement, we need to state that two figures are congruent, and we need to make sure that the corresponding vertices are in the same order, and there's more than one way to write it. So for the first one, if I write triangle ABC, then I need to make sure my sides are matched up accordingly in the other triangle. So I need to start with my triangle symbol, the side or the vertice that is congruent with angle A. If you look in our picture over here, is letter F, because they have the same congruent symbol. So my first letter in here will need to be letter F. Next, the letter B is congruent to angle E, so that needs to be my next letter. And angle C is congruent to angle D, so that needs to be my next letter. So really, the first way you set it up does not really matter, as long as the second way, the one you write that's congruent to it, needs to be lined up accordingly. So here's another way you could have written it. Triangle CBA is congruent to triangle DEF, and if you notice, the C and the D are still paired up, the B and the E are still paired up, and the F and the A are still paired up as well. So next, since we have congruent triangles, we have three sides that are congruent to three sides, and we have three angles that are congruent to three angles. So for the first one, we know that angle A is congruent to angle F. Then after that, we said that angle B is congruent to angle E. And lastly, we know that angle C is congruent to angle D. We can also get this just from the congruent statement up above. If you notice, if A is congruent to F, B is with E, and C is with D, we don't even necessarily need the picture anymore if we have this congruent statement. So next are the sides. So if I pair up AB together, then that means that FE need to be congruent to AB. So if I write BC, then I need to have ED is the next side that's congruent to it. And that's because up here we see that BC is the second and third letters, and ED is the second and third letter. So last one I have not paired up is my A to my C. So AC then would have to be congruent to FD. So next I would like you to do the same thing now with these two triangles down below, that I want you to write a congruent statement, so stating which two triangles are congruent, and then I want you to pair up all these sides that are congruent and all the angles that are congruent. This is what I have for my congruent statement. So the first one I wrote as triangle JKL. The second one, then I need to look at each individual letter. So I see J has three little marks, so T is the first one that goes with it. K has one mark, so S will be the next angle. L has two marks, so R has two marks. The corresponding angles that would be congruent would be angle J to angle T. Angle K would be congruent to angle S. And angle L will be congruent to angle R. And if you remember what I said earlier, you can actually get that from the congruent statement itself. You don't have to look at the picture all the time once you get your congruent statement set up. So next, JK. So the side JK is congruent to side TS. And then KL is congruent to SR. And then JL is congruent to TR. So if you remember, once we say that two figures are congruent, we can match up any of the corresponding sides and say that they're congruent, and we can use those to write an equation to solve for x or y. So in our picture, if you notice up here, this 2x minus 4 is the RQ, so that means that FG is congruent to it, this 12 right here. So an equation we could set up would be 12 equals 2x minus 4, which means 2x equals 16, and so x equals 8. So if you notice where the y is at, we have 6y plus x, so that really is 6y plus 8. And this comes from angle Q, So if you look where my angle Q is at, that means the angle F is congruent to it. So my angle F is the 68. So I know that 6y plus 8 should equal 68. So I can use that to solve for y. So I get 6y equals 60. So y itself is going to equal 10. In this next picture, if we assume that the two figures are congruent, I forgot to write that in there, and I want you to find what the value of x is. So if you notice, the c and the d match up with my a and b, so this 105 then would be corresponding to the 4x minus 5, plus 5. So our equation would be 105 equals 4x plus 5. So when you subtract the 5, we get 4x equals 100, and when you solve for x, you get x equals 25. It's also asking us to go back and find what the value of h, angle h is, so we need to put it back in there. So 4 times 25 is 100 plus 5 is 105. So this next one, if you look at my picture, you can see the orange and the blue on mine, so you might want to make a note on your notes about which side is the orange is the left and the blue is the right side of the wall. But the JK divides the wall into two different portions, and will those two portions be congruent? So are they the same size and shape? And if you notice, if we can match up all the angles are congruent to other angles in the other side, and we can say that all the sides are also matched up, then yes, we can say that they're congruent. So if you notice, we have a couple sides that are already congruent, so that would be our AD is congruent to BC. We also have that DK is congruent to JB, and we have that AJ is congruent to KC. The only part that we're missing is the JK in the middle. We know they should be congruent because they're sharing that side. They should be identical. We don't know what they are, but we know that they will be the same size. For the angles, we have two of the angles that are congruent, but we do not know about angle 1, 2, 3, and 4. But if you notice, if we have 4 corners that are 90 degrees, so A, B, C, and D are all 90 degrees, that means that DC is parallel to AB, and BC is parallel to AD. That means that this is a transversal line going through it, so our alternate interior, so 1 and 4 will be congruent, and another set of alternate interior, 2 and 3, will also be congruent. Since we've gone through and shown that all parts are going to be congruent, we know that the orange is going to be congruent to the blue side. So I'd like you to do the same reasoning for this next triangle. So if you notice, it already points out that two sides are parallel to each other, so you can use that with your alternate interior angles. There's also some vertical angles in there that are missing that you might need to say something about. So go ahead and try that and work out your reasoning, and then push play to check against mine. Alright, so we know that the vertical angles in the center, so PTS and QTR, will be congruent to each other. We also know that there's a set of alternate interior angles, that would be either angle S and angle Q, and your P and R will be congruent because of the parallel lines. So this shows that you have all angles and all sides are going to be congruent, so you can say that those two triangles will be congruent. In this third angles theorem, we know that if two angles of one triangle are congruent to two angles of another triangle, then the third angle is also going to be congruent to each other. So the third angles will be congruent to each other. So in the picture down below, one thing we might want to do is draw the two triangles separately. And if you see my pictures, that if I have two angles that are congruent to two angles in the other triangles, that we know that the angle C must be congruent to angle D. So all we need to do is subtract from 180 the 45 and 30, and we end up with 105 degrees. So when they're asking for the angle BDC, BDC then is the 105 degrees. You see in this picture, you can see that angle D is congruent to angle S, so it's also 68 degrees. And in the triangle on the right, we know we are missing an angle right here. So if this is 75 and 68, we know that if we subtract those from 180, that we will get the missing angle. But also we know that the two angles in the center right here have to be congruent to each other because they are vertical angles. And we have two angles in each triangle that are congruent to each other, so therefore the third angle must also be congruent. So angle C must be congruent to our angle R. So that means that our angle DCN should equal 75 degrees. down here, the three properties at the very bottom are going through that if we have triangle ABC, if we label it as triangle ABC, we can say that it's congruent to itself, so that's a reflexive property. The symmetric property is that we can mix around, so if we are given that triangle ABC is congruent to triangle DEF, then we can switch the order of it and it's still congruent to each other. The transitive property is if we first say that triangle ABC is congruent to DEF, so say triangle 1 is congruent to triangle 2, and then we say triangle 2 is congruent to triangle 3, that then we can pair up the first and the third ones, then should be congruent as well. We're going to see that pretty often when we get into proofs later in the year.